integrating standard functions part 2. So we're integrating functions of the type where you have a constant in the numerator and a linear function of x in the denominator. So you get a natural log. We have to use this modulus notation, and we can see that the ax plus b, the linear function, goes in here, but we're dividing by the coefficient of x, which is a. Now this can be rewritten in this form as well, giving you the same result. If you write this as the power of 1, and then you bring out the ax plus b, then you change the sign on the power, so you get ax plus b to the power of minus 1. So these are the same. Okay, so integrating here, we have a constant over a linear function. I'm going to take out the 2/3, because the 2/3 is multiplying with the 1 over x. 2 times 1 is that 2, 3 times x is that 3x. And now I'm going to integrate. So this is what I'm working on. So integrating 1 over x will give ln x times that 2/3 plus some constant. Here's a longer version of the same thing. So ln, and the linear function is 3x, and I don't have to use the modulus here. The modulus is useful when you're, so if I'm going to do this, that's useful when you have limits of integration, really useful. That's what you would do if you had limits. Without limits, you can use normal brackets. There, so we've got ln 3x, I'm dividing by my coefficient of x. I was multiplying by 2, I need to multiply by 2, and I have a constant of integration. And now the ln 3x can be split up using the multiplication law for logs. So the 2/3, if I leave the 2/3 here, then I can write this as ln 3 plus ln x plus c. If I remove the brackets, I've got 2/3 ln 3 plus 2/3 ln x plus c. We have a constant here, that's a constant term, that's another constant term, and we can combine those two constants into another constant. Let's call that new constant d. So then I've got 2/3 ln x plus some constant, where the d is equal to 2/3 ln 3 plus c. And this result is the same as this. The letter used for the constant is of no significance. The results are the same. In this example, again, we have a constant over a linear function, so I'm going to get a log. Again, I can use brackets or the modulus notation, it doesn't really make any difference. 1 minus 2x, because I don't have any limits, so it doesn't matter. I'm dividing by the coefficient of x, which is minus 2. I was multiplying by 4, that goes here, plus c. And that 4 divided by that minus 2 will give minus 2, so I can simplify like this. And we can also write the final answer like this. That's a 2x minus 1, that was a 1 minus 2x, just to show that these are the same when you do their modulus. When you do the modulus of something, you never end up with anything negative. That's the same as if you square something, you never end up with anything negative. So let's see what happens to these two when we square them. They are exactly the same.